Wonderful Sunday. Okay, today it's a wonderful Sunday. So today we are going to discuss about the topic called gravitation. So this is a very important part. Okay, so especially in the IIT and the mains point of view, this is a very important topic. Okay. Yes, Prithviraj, good morning. And Sai Praneeth, Abhiram. Okay, very good morning to all of you. Okay, see actually the Streamlabs they changed a little bit, so that's why I was a little bit confusion is there. Okay, now I think it is all right. Okay, see very good morning to all of you. So see carefully here. Today we are going to discuss about the gravitation. See, gravitation means what here? Yes, Kirti, good morning. See, gravitation means what here? So basically in this one we are going to discuss about the force between the masses. And here we are going to answer very important questions like okay, how the earth is rotating around the sun and how the moon is rotating around the earth. Okay, and how the things are happening. Suppose you drop an object, see how it is going down, means how it is reaching the earth, with what acceleration it is reaching the earth. Okay, and also see we are going to discuss about see with what speed the satellite has to be launched, okay, in order to reach a certain height. And also see we are going to discuss about what must be the velocity to be given to the satellite so that it will rotate around the earth. Or you wanted to reach Mars, you wanted to reach beyond that, then see how we can go that one. So all the different questions are there, especially so the gravitation part is very interesting one. So see all these things we are going to discuss, but see here it will take around 3 weeks time, because see, okay, the time adjustment I am unable to do. Okay, that's why I am teaching only on Sundays now. Only on Sundays I am going to teach. So please kindly adjust with me. But remember, I will be completing the entire syllabus by what is called means by the next the upcoming that is called the NEET exam or the IIT mains exam. So I will try to complete. Okay, but thing is that please see your preparation is very important. Yes, Ananya, good morning. Okay, see remember your preparation is very important. And see tomorrow onwards, see what I am going to do. See I am going to put every day the 3-minute videos. Means in a 3 minutes I am going to discuss one concept, and you are supposed to prepare that one, and you have to follow means that particular concept. See one concept a day, and that too within 3 minutes. But see here, to get that 3-minute knowledge, see what you have to do, you have to work for at least 1 hour later on. Then you will get that complete concept very easily. Okay, that I am going to start tomorrow. Okay, because of the time constraint. But remember, every Sunday the classes will be there, the live classes will be there, the live free classes will be there as usual. Okay, so thank you all for coming to my class. Okay, see carefully today what I am going to discuss. I am going to discuss in gravitation. In gravitation we are going to discuss two concepts. See, one is called as the Newton's universal law of gravitation, and the second point is called as the acceleration due to gravity, and how the acceleration due to gravity varies with the height, depth and rotation. So there are the points we are going to discuss today. And see there will be in the description, see one worksheet will be there. Please try to do that worksheet. I think in the last class we discussed about what is called the optical instruments. So I gave you the worksheet also. I think you might have done that worksheet. Okay, see everyone, please do the worksheet, and please do the additional materials also. See as many materials as possible. Please try as many sums as possible. That will help you a lot. Okay, thank you all. Okay, now see carefully. See, let us start with the Newton's universal law of gravitation. So what is Newton's universal law of gravitation? Okay, see actually the Newton's universal law of gravitation is a breakthrough regarding the understanding of, yes Mohit, good morning. See, in order to understand, see what is called the nature of this universe and all. See here, before Newton, See, everyone used to think that, okay, the God is rotating the earth, the God is rotating the sun. Okay, say, suppose, for example, I just remember, see here, the Ptolemy's theory is there. See, according to Ptolemy, the earth is the center of the universe. Means here that is called a geocentric theory. See, what is the geocentric theory? See, according to geocentric theory, see, every object in this universe is rotating around the earth. But see, later on it was corrected by Copernicus. See, the Copernicus said about the heliocentric theory. So what is this heliocentric theory? It means according to heliocentric theory, what is that is called, the sun is the center of the universe. And say he predicted that it's an elliptical orbit. But say later on Johannes Kepler, see, he concluded that, see, the planets revolves on the sun in an elliptical orbits. Okay, the planets revolve on the sun in elliptical orbits. Okay, see, okay, that is, okay, that Johannes Kepler, the Kepler's orbital theory, the Kepler's theory and all, I will be discussing in the next class. Yes, Shashank, that is correct. Okay, sun is in the middle. Okay, sun is the center. Okay, now see carefully. See that Kepler's law we will discuss. Okay, now the thing is that, see how these objects can rotate. Okay, how these objects can rotate around sun, or how these planets are placed here. See that no one could give a proper answer for that one. Okay, see, the Galileo is the one who experimentally tried to prove this one, but he was failed. But remember that Newton was successful in explaining this Newton's universal law of gravitation. Based on that, he could explain how the earth is rotating around the sun and see how the objects can stay, okay, in an equilibrium position. That he could explain. See, why he could explain, do you know? That's because of his mathematical knowledge. See, the physics you can understand very well only when you are very good at mathematics. See, the Newton developed the calculus part of the mathematics. Okay, the calculus part of the mathematics was developed by Newton to understand this gravitation. Means gravitation means what? It is nothing but the attractive force. Remember, the gravitational force is always attractive. Okay. Now see, anyhow, let us come back to this Newton's universal law of gravitation. So according to Newton's universal law of gravitation, the force of attraction, please remember, see, it is always, see, the gravitational force is always a force of attraction. Okay, there will be always an attractive force will be there. Maybe in the minute levels of the masses, maybe there may be repulsive force may be there, but in general, please consider it as an attractive force only. Okay, see here the force between any two masses. See, according to this Newton's universal law of gravitation. See here, for example, if we take two masses, see, let us say two masses. The two masses, see, may not be like Earth and the Sun. It can be you and me, or between a book and the pen. See, any two masses you can take. Okay, see, let us say that this is M1, this one is M2, and see, let us say they are separated by distance R. Okay, if they are separated by distance R here, then see here, the force between any two masses is what here? See, the force between any two masses is directly proportional to the product of their masses. Okay, and see here, see, F is inversely proportional to the square of the distance between them. Okay, yes, Vijay Kumari. Yes, good morning. Okay, see carefully here. See once again, see the force between two masses. Okay, see here the force between two masses is directly proportional to the product of their masses. Okay, and the force between the two masses is inversely proportional to the square of the distance. Okay, then see carefully here. Then F is directly proportional to what here? See M1 M2 by R square. Therefore, F is equals to how much here? G M1 M2 by R square. Okay, see carefully. The force between the two masses. Okay, the force between the two masses can be written as G M1 M2 by R square. See here, what is this G is called as? The G is called as universal gravitational constant. Universal gravitational constant. And see here, what is the G value here? The G value is nothing but, see here, 20 by 3 into 10 power minus 11 Newton meter square by kg square. Or here the G value is nothing but 6.67 into, see, 10 power minus 11 Newton meter square by kg square. And remember, see carefully here, they have written that, see, it's a universal gravitational constant. Means a universal means what here? Means it is constant. It is constant in any case. And see carefully, the value of G is independent of medium here. So for example, let us say if I place them in a liquid of density D. Suppose if they place them in the liquid in the liquid D of density D, then tell me what the force between them. So the force between them is same only. It doesn't change at all. See why it doesn't change here? That's because of the G is a universal gravitational constant. Suppose for example, see in between I placed a huge wall here. So if I place a huge wall between them, then tell me what the force between the masses. Again the force between the masses is same only. It doesn't change at all. Means if any object comes in between, the force doesn't change. Suppose for example, if it is placed in another medium, then it doesn't change. The force remains as it is. See, that's why here, see carefully. Here, suppose this is the sun. See, around that one, see so many planets and the asteroids are rotating. See, sometimes we used to hear that the planets came in a straight line. Means in between the planet there are so many obstacles came. But is the attraction changed? Did the earth fallen down? No. Why? Because the force between any two masses is independent of the medium. It doesn't change at all. Okay, are you following what I am saying here? Okay, I hope you understood this one. See here, the Newton's universal of gravitation states what here? The force between two masses is directly proportional to the product of the masses and inversely proportional to the r square. See here carefully. Let us see carefully. Okay, now see carefully here. Let us say let me give you one sum here. See, let me give you one small sum here. See, what is a small sum here? See, let us try one example. See the example 1. See here, let us say the m1 value is 1 kg and the m2 value is also 1 kg. See, let us say the r is equals to 1 meter. Okay, see let us say the G as G only. See throughout, see whatever the sums I am saying here, see throughout this one, please use the G as G only. Don't substitute the value of G. Okay, now tell me what the force between them. So what is the force between the two masses here? So what is the force between two masses here? See carefully here. See what is it here? See m1 value is 1 kg, m2 value is also 1 kg. See let us say the distance between them is r equal to 1 meter. See the G value is G only. Then tell me what the force between the masses. So the force between the masses is nothing but G m1 m2 by r square. So I want every one of you to participate in this one. Please answer this one. Okay. Therefore you see here everything is 1. So therefore G into 1 by 1 square. It is nothing but G Newton. Yes, good. Good, Mohit. Good. Okay, see the value of G is nothing but 1 Newton here. Oh, sorry, G Newton here. Okay, good. G Newton. Good. Okay, now see the example 2. Now see the example 2. Okay, see carefully here. Let us say here, see what they are given here. They have taken two spheres here. Okay, they are given two spheres here. See, let us say their densities are rho. Their densities are rho each. Okay, and see here the distance between them is r here. The distance between them is, okay, this is also radius r, this is also radius r. Okay, now tell me here, what is the force between these two masses? Okay, see carefully here, see here what they give. The density of this sphere is rho. See, remember this is a sphere, this is a solid sphere. This is a solid sphere. They did not give mass. So they did not give mass here. See here, they have taken two spheres here. See, the two spheres are separated by distance, okay, radius r here. Okay. Sorry, excuse me. It's good, Vijay Kumar. You see carefully here. See, they are separated by distance. See their centers. If you see carefully here. See here, what the distance between their centers here? The distance between the centers is nothing but 2r here. The distance between the centers is 2r here. But see carefully, what is missing here? The mass is missing here. See, the mass quantity is missing here. See, I did not give mass here, but see, I gave the density here. Then here, see here, yes, good. Good, Ananya, good, very good. Okay, now see here, now concentrate on this one. Now see carefully, see here, I given two spheres here. The two spheres each of radius r, and say their densities are rho here. Therefore, see now tell me what is m1 equal to, m2 equal to how much here? It is nothing but the density into volume. Okay, say what is the density? Density into what is the volume here? 4 by 3 pi r cube. Okay, density. Okay, see carefully, the density, see here, mass equal to density into volume here. Okay, now see here, what is the force here? The force is equals to G m1 m2 by r square. Therefore, F is equals to G. Okay, what is m1 here? See here, rho into 4 by 3 pi r cube. See here, rho into 4 by 3 pi r cube. Multiply, see what is the distance here? 4r square, because it's 2r whole square. Okay, density equal to mass by volume, but say mass equal to density into volume. Use that one, Mohit. Okay, so therefore here, see what is the force here? See here, rho square, see g rho square, 4 by 3, 16 by 9 pi square. So r to the power of 6 by 4r square. Means r square, how many times it will cancel here? It is nothing but the r to the power of 4 times. As r to the power of 4 times, therefore see what we will get to see, this is 4 times cancel. Therefore you have 4g rho square by, see 4g rho square by 9 pi square multiply r to the power of 4. Okay, see here, see what I am trying to say here. See, sometimes they'll ask, see here, see sometimes they see here we got F is inversely proportional to R square. Suppose if the density is taken into account, instead of mass, see the force is directly proportional to the rho square R to the power of 4. See, very, very important point. See carefully here. Suppose if the density is taken into account, okay, if the density is taken into account, the force is directly proportional to rho square multiply r to the power of 4. Okay, so are you following what I am saying here? Okay, now, see, let us look at another important point here. Okay, let us look at another important point. I hope you understood this one. Okay, now. Okay, see carefully here. See, just now here what we discussed here, we discussed about the force between the masses. See, when you are discussing the force between the masses, you see, observe here. Suppose, see, let us say this is one mass. See, this is another mass here. Okay, see, let us say this is a mass m1, this is a mass m2. Okay, now here suppose I wanted to find the vector form of Newton's universal law of gravitation. See here, you must learn this vector form. Why? Because say force is a vector quantity. The force between the masses is an attractive in nature. Then here how you can explain the direction of that force here. See here, once observe carefully, here m1 and m2. So when you look at m1, see m1 attracts m2 and also m2 attracts m1. Okay, all these two forces are different or same. Okay, please remember here, the m1 attracts m2 and m2 attracts m1. See, their forces are equal, their magnitudes are equal, but remember their directions are different. You see carefully, see, have you understood this point here? See, remember, see, their magnitudes are same, but their directions are different here. See, then how you can write on this one? See, let us say the distance between them is r. Okay, the distance between them is r here. Okay, then see, can you see here what is the force acting on? See, what is the force acting on M1 here? See what is the force acting on M1? See, M1 is attracted by second one. Then how much force is acting on one? See, that we can call it as F12. Okay, see carefully see here. See what is the force acting on? What is the force acting on one? So force acting on one is due to 2. So therefore, how you can write it? See, F12 is nothing but, see what is the direction of F12? What is the force acting on 1? It is nothing but attracted by 2. So it means attractive. Attract, there is no repulsive. Attractive. Okay, are you following? Then see, this is F12. Then see at the same time, see the 2 is attracted by 1. It is nothing but F21. Means it is nothing but C here. See, it is nothing but C minus F21. See why I wrote minus F21 here? Because it's in opposite direction. But remember, see, both are nothing but G M1 M2 by R square only. Okay, why I wrote R square? Because the distance between them is R. And see what the force formula? Nothing but product of masses only. So means I see this one is same only. But remember, see what is the difference here? The directions are different. And see here, and one more important point here. See, with what you are acting means here on what the force is acting. That you should see every time. You see carefully. Let us see one simple example. See here, what is this simple example? See, take one example. See here in this example I have given 4 masses here. Okay, let us say here is one mass. So here is another mass. This is another mass. Okay, this is M. See here, let us say the distance is A. Okay, see, let us say this one is 1, 2, 3 and 4. Okay, now here the question is find the force acting on M1. See, find the force acting on M1. That is the question I am asking. Then how to do this problem? See carefully, see here, M1 is attracted by whom? See, the M1 is attracted by M2, that the second mass. See, M1 is attracted by fourth mass, is attracted with third mass also. Okay, see once observe here carefully. See, let us say, see F1. So force acting on 1 due to 2. The force acting on 1 due to 4. And the force acting on 1 due to 3. The 3 forces are acting. And see carefully, this is A, this is A. See what is the distance here? This one is root 2A. Okay. Now first let us calculate F12. And see if you observe carefully, F12 and F14 are equal. So F12 is equals to F14 is equals to, what is the formula? Gm square by A square. Isn't it? And here, see carefully once, okay, here I will draw here, see carefully. This is F12. See, this one is F14. Okay, now tell me what is the resultant of these two here? The resultant will be, let us say, this one is R1. And here, what is the angle between them? The angle between them is nothing but 90 degrees. So here, what is R1 value? R1 value will be definitely the root 2 value. Because see, both are 90 degrees each other. So they were root 2 Gm square by A square. That is the R1 value. See, at the same time, there is another force is also acting here. What is that one? That is nothing but F13. You cannot tell me what is F13. See, F13 is equals to, see, the distance is root 2A. Therefore, here G M1 M2 means nothing but M3 M square by, see how much is this? The distance is root 2A whole square. The root 2A whole square. Therefore, it is nothing but here, see, Gm square by 2A square, that is F13. Now see carefully observe here, see R1 is also acting in the same direction, F13 is also acting in the same direction. Therefore, yes, very good Sai Praneeth. They want to tell me what the resultant force here. See the resultant force, or we can say the net force is nothing but, say, R1 plus F13. Okay. Therefore, here, what is F net here? See the F net is nothing but see R1 value is how much here? So root 2 gm square by a square plus gm square by 2a square. Okay. So therefore you see what is the F net here? So the F net is nothing but see gm square by a square. Okay. Square root root 2 plus 1 by 2. This is the final answer. Okay. See, are you following what I am saying here? See carefully here. See here, there are 4 masses are there. Okay, there are 4 masses are there. See, in these 4 masses, see what we got here. See here, the force acting on one I am asking. Okay. 1 second. Okay. Now see carefully here. See how you understand. See there are 4 masses are there. The 4 masses are there. See what is the force acting on one I am asking. See 1 means what I see this. 1 is attracted by 2. The 1 is attracted by 4. Okay. And also see the 1 is attracted by 3 also. See first we found F12 and F14. See F12 and F14. See their resultant is R1 here. And next here what we did here, we found F13 and that is also in the same direction. So that's why see we just added all those. See remember this is an attractive force. As it is an attractive force, here what we have to do here. See what we have to do here, you have to take the directions the directions are very important. So whenever you are solving the sum, please take the proper directions and please try to do that sum. See here in the description box, see I'll be giving you some more problems. Okay, please try those sums. Okay. Okay then, see let me rub this one. Okay, now see carefully. Okay, now here see next what we are going to discuss. See next we are going to discuss very important point called mass. See carefully here, mass means m. So what do you mean by mass here? See mass is nothing but it's a quantity of matter. See the quantity of matter contained in a body. Okay, the quantity of matter. Okay, the quantity of matter contained in a body is called as mass. And see carefully here, the unit of mass is what here? The unit of mass is nothing but the kg or kilogram. And remember see here, mass is a scalar quantity. See mass is not a vector quantity. See here many students have misconception. See they'll always confuse with the mass and the weight. Okay, they'll always confuse with the mass and the weight. Okay, see mass means what here? Mass is nothing but it's a quantity of matter. Weight is what here? The force with which a body is attracted towards the center of the earth. That is called as weight here. So it means see here, once you look at me, say I was attracted by the earth, but I am not stick to the earth. Okay, that is different. See, are you following what I am saying here? See carefully, see here, I am stick to the earth. See, I am not stick to the earth. I was attracted by the earth. See, with what force I am attracted? Equivalent to my mass and the acceleration due to gravity. Okay, see, suppose if I am having more mass, the more attraction. So if I have less mass, less attraction. See how a paper can float. A paper will float because of its less mass. See how the air can move this side and that side because of its less mass. Okay, less the mass, less the weight, more the mass, more the weight. So here carefully, next see carefully, weight. See here, what do you mean by weight here? See, weight is nothing but the force with which a body is attracted towards the earth. Okay, it is nothing but the force of attraction. The force of attraction. Okay, the force of attraction towards the earth. See, that is called as weight here. Okay, with what weight you are attracted by the earth, that is most important here. Okay, see, that is nothing but the weight here, that we call weight. Okay, please don't get confused with the weight and the mass. See, weight is measured by the spring balance, mass is measured by the common balance. Weight is a vector quantity, mass is a scalar quantity. And see carefully here, what is the unit of weight here? The unit of weight is nothing but the kg force. Okay, or we can also write it as, see, the kg weight. Okay, suppose for example, if I take this is surface of the earth, then see, if an object is placed here, a mass m, it is always attracted towards the center of the earth. Okay, so are you following? Yes, Amritavarshini, good morning. See, the force with which a mass is attracted towards the center of the earth, see, that is called as weight. Okay, then come to the another important point. This is called as acceleration due to gravity. Okay, acceleration due to gravity, that is G. See, what is this acceleration due to gravity? See here, there only in the question itself the answer is there. See, there is an acceleration is produced. See, how does the acceleration produced here? That is due to gravity. That's why it is called as the acceleration due to gravity. Means gravity means what here? Nothing but the force that what we discussed now. See here, suppose for example, see, this is the surface of the earth. Suppose let us say if I just drop a body here, then tell me in which direction the body will travel. Usually in general, see, it will travel towards the earth. See, at first its velocity is 0. But see, when you just release here, what happens? It has gained some velocity or not? It has gained some velocity or not? Means what here? Definitely there is an acceleration is there. See, that acceleration we will call it as acceleration due to gravity. Even though the object is at rest, there is a gravity is there. The g value will be there. Okay, that g is called as acceleration due to gravity. See, what do you mean by acceleration due to gravity? It's nothing but acceleration produced. Okay, acceleration produced due to the earth pull. Okay, because the earth always pulls the object downward only. See, for example, if you look at girls, okay, or the boys also, okay, see here, their hair always goes down, it doesn't go up. Is our hair is growing up or down? Why we don't have the plates like this? Why? Because the gravity. See, the nose always down. Okay, your shirt and pant, whenever you are wearing, see, they always go down. Okay, means there are general things I am saying here. Why? Because the earth always pulls all the objects towards the earth. Okay, that acceleration produced in that body is called as the acceleration due to gravity. Okay, see, the acceleration due to gravity, the G is nothing but the 9.8 meter per second square. Okay, the 9.8 meter per second square on the earth surface. This is on the earth surface. Okay, then tell me, then how we can find the value of G on the surface of the earth or on the any other planet? Okay, see, observe here carefully. Okay, now see, observe here carefully. So let us say this is the surface of the earth. Okay, this is the earth. So the mass of the earth is m. Okay. See here, the mass of the earth is m. Okay. See, let us say the radius of the earth is r. See, r is what here? The radius of earth. Radius of earth. See, what is m here? M is the mass of earth. Okay. Now here, see carefully here. Let us place an object here. At any place you keep, you may place here also, it doesn't fall. So it is always attracted by the earth. Now see carefully here, let us say if an object is placed here, so this is the center O. So this mass is attracted by the earth. Therefore now tell me here, Now tell me here, see what the gravitational force here? See F is equals to Gm m by r square. So what is the m here? The mass of a body. Okay, m is what here? M is the mass of the body. See here, F is equals to what here? Gm m by r square. Okay, there is a force between the two masses according to Newton's universal law of gravitation. But at the same time here, see we also have here the force, that is the weight here, the weight which is acting there. Now tell me what is the weight acting here? It is nothing but mg, mass into acceleration due to gravity. Now you see here these two forces are equal and opposite. See carefully here, the weight is acting on earth. The weight is acting on earth, that is the first body. And the second body is what here? The earth is acting on m. That is nothing but the gravitational force. Are you following? See, the mass is acting the weight on the earth, and the earth is acting the force on the mass, that is nothing but the Newton's universal law of gravitation, that force we got here. Now say, let us equate these two, the action reaction. Sorry. Okay, therefore here what I can write here, I can write mg is equals to Gmm by r square. Therefore what I can write is, see, mm get cancelled. Therefore g is equals to how much here? Gm by r square. See here, once observe here carefully here. See here, once observe carefully. This is very, very important point. See, the acceleration due to gravity does not depend upon the mass of the body. Why? Because see here we got that g is equal to gm by r square. Okay, g is equal to gm by r square means what here? See here, the acceleration due to gravity is independent of the mass of the body. Okay, now see, let us quickly try another important point. And see, just now we discussed one more important point. What is that one? See, the mass can be written as, see here, observe here, see, the mass can be written as the density into volume. So rho means what here? The density of the earth. Okay, density of the earth here. So therefore see, once observe here, see, mass equal to density into volume. The mass equal to density into what is the volume here? The volume is nothing but 4 by 3 pi capital R cube. Okay, see, let us substitute that one here. Therefore see, what is the g value? The g value is nothing but see here, g by r square multiply rho multiply 4 by 3 pi r cube. Therefore what you can write here, see, the g can be written as 4 by 3 g pi r rho. See carefully here, suppose if the mass is taken into account, if the mass of the earth is taken into account, see, the g value is inversely proportional to r square. Okay, suppose if the density is taken into account, then see carefully here, the g value is directly proportional to the r, that is the radius of the earth. Means here, more the radius of the earth, more the value of g. And also one more important point, see carefully here. Say for example, if you look at the earth, the value of g is 9.8. See the g value on the earth is how much here? It is nothing but 9.8 meter per second square. But the g value on the moon is how much here? It is 1.67 meter per second square, or its value is g by 6. Why it is like that? Because the mass of the moon is less than the mass of the earth. Okay, see here, the mass of the moon is less than the mass of the earth. See here, g is directly proportional to m. More the mass, more the value of g. Less the mass, less the value of g. But at the same time, see carefully here, the g of sun is 27.4 meter per second square. Why? Because the mass of the sun is much greater than the mass of the earth. So that's why here, see carefully, the value of g basically depends upon what? The mass. So if I consider this one, the density. So more the density, more will be its acceleration due to gravity. Okay, are you following what I am saying? See, suppose for example, if you go to space where there is no object is there, then the g value will be definitely 0. Why? Because there is no one to attract. See why we got the G value here? Because someone is attracting us. And why we are all stick to the earth? Again because of this gravitational force only. And why the earth is rotating around the sun? That's because of this G only. Means the G means the force of attraction between the masses only. That is always constant. Okay, please try to understand, very very important point. Now see, let us see carefully the value of G. Let us discuss more about the value of G here. Okay, now see, observe here carefully. See, the value of G means I am talking about the small g. See, capital G is always constant. There is a universal gravitational constant. See, what I am talking here. See, I am talking about what is called the small g. See, the small g always varies. It is not constant. So, for example, I am in Visakhapatnam. See, Visakhapatnam, the value of g is different from, say, from let us say in Delhi or in Mumbai or let us say in New York. The G value will be definitely different from here. The G value always changes. From place to place it will change. From depth to height also it will change. And also because of the presence of the hills and in the presence of surroundings also, the value of G will change. Means that G is nothing but it is produced due to the attraction. So that's why the value of G is not at all constant. See, let us see the case 1 here. So around 4 cases I will try to discuss. See the case 1 here. See, this is called as the variation of G due to height. Okay, the variation of G due to height means here if you are going away from the surface of the earth. See carefully. Suppose let us say this is the surface of the earth. Let's say this is the R is the radius of the earth, M is the mass of the earth. Okay. Yes. Good morning, Amrita Varshini. Okay. Now see carefully, see M and the radius is R here. Okay, now see carefully, suppose see if you are going away from the surface of the earth, let us say you reached a height h, then see at a height h, see what is the value of G, then how we can find? See carefully, the G value on the surface of the earth is nothing but see just what we got here, Gm by R square. Okay, the mass is constant here. See, at a height h, now see at this point, now tell me what is the value of G? Let us write it as GH. The G due to height. So GH is equals to Gm by R plus h whole square. Okay, now here let us do the GH by G. What is GH by G? It's nothing but Gm by R plus h whole square by Gm by R square. Therefore, this can be written as R by R plus h whole square, or nothing but you can write here, so the G value due to height is nothing but G into R by R plus h whole square. This is the value what we are looking at. Means here see, when the value of say for example the height is more, then what will happen? When the height is more, then definitely the denominator value increases, the G value decreases. Means here the value of G decreases due to height. Okay, the value of G decreases due to height. Okay, next see carefully. Let us do a simplification of this one. So you can also write on this one, GH is equals to G multiply R plus H by R to the power of minus 2. Okay, or if not see carefully, GH is equal to G into 1 plus H by R to the power of minus 2. See, let us do the binomial expansion. If it is the binomial expansion of the one term, therefore GH value is how much here? G into 1 minus 2H by R. But remember, see carefully, every time please try to use this formula only. Don't use this formula. This is a reduced expression. See, this you can use when the H value is much less than R. Like 100 kilometers like that. But see, this one you can use at any instant. Okay, greater than or equal to or in less than or also you can use. But remember, this is the reduced formula. Only in few cases we are using. Only in few cases. See, for example, I wanted to know the percentage change. Then how can I find? See, observe carefully here. So I do one thing here. See, GH is equals to G minus 2gh by r. Okay, therefore here gh minus g, or if not say I will do one thing, see 2gh by r is equals to g minus gh. Okay, or if not see here I can write down this one as g minus gh by g is equal to 2h by r. Means this is called as a fractional change in the value of g. See what is the fractional change? See, this is called as the fractional change. The fractional change in the value of g is nothing but the 2h by r. Suppose if they ask the percentage change, then how can I find the percentage change? It is nothing but here 2h by r percentage. Are you following what I am saying here? See carefully once again. The variation of g is due to height. See here when you are going away from the surface of the earth, then see what will happen? The value of g gradually decreases. See the value of g gradually decreases here. Means remember, see if you go height is equals to infinity, that time only the value of g becomes 0. In the middle it won't be 0 at all. Means here you should go the infinite distance. Until the infinite distance the value of g will be there only. Means it is there but it's very less. Okay, please try to understand this one. Okay, please don't use this formula except only in some exception cases. Okay, see let me write this one. Suppose if you are unable to copy, please copy later on. Okay, now see carefully here the variation of g due to depth. Okay, next is another case here. This is called as the variation of g due to depth. See how the value of g changes due to depth. Means see here when you are going depth, then what will happen here? See this is a very important case. See carefully, suppose see, let us say this is the surface of the earth. Okay, let us say the radius is r, the mass is m. Okay, suppose say for example you went to a certain depth. See let us say you went to a depth d. Okay, when you went to a depth d, then what will happen? Then see here the mass of the earth. So the mass of the earth will be m dash here. Why the mass of the earth is m dash there? Because see, when you are going to the depth, the mass changes. The effective mass of the earth will change. And the effective mass of the earth will change. The value of g also will change. Because see, for example, if you are standing here, then the whole mass of the earth is acting on you. But say when you are standing here, only which part of the earth is acting? Only this part of the earth is acting towards center. Okay, so that's why here what will happen? See, when you are going to the depth, the effective mass is changing. The effective mass of the earth is changing here. See, once you observe carefully, here we know that. Okay, this one instead of taking a masses and all, we will do in a density method. See, carefully we know that g on the surface of the earth is how much here? 4 by 3 g by r rho, where rho is the density of the earth. Then see here the g due to depth. Say how much depth you went here. Okay, you went to a depth d, means remaining is how much here? R minus d. Say let us take only r minus d. The density doesn't change. Okay, the density doesn't change here. Only it changes what here? The radius is changing. Therefore here the 4 by 3 g pi r minus d into rho, where d is the depth. Okay, d is the depth here. Okay, therefore here let us do the gd by g. What is gd by g? The gd by g is nothing but here 4 by 3 g pi r minus d multiply rho. Okay, by 4 by 3 g pi r rho. Okay, now see, let us cancel this one. Therefore here what is gd by g? The gd by g is nothing but gd by g is nothing but here r minus d by r. See, everything other will be cancelled. Or if not, you can write down this one 1 minus d by r. Therefore what is g value due to depth? It's nothing but g into 1 minus d by r. So that's the g value. Suppose if the d value is r here, then the g at this center is 0. See, where does the g value is 0 here? G value is 0 at the center. See, by the time it reaches to the top here, then see the depth value is 0. then the G value is G. Again, when you are going away, then what is happening here? Again, it is decreasing. Means if I draw a graph here, see if I draw a graph between the value of G and the distance here. See, at the center it is 0. And see, gradually it is increasing. See, it is nothing but, see, if you observe here, it is directly proportional to R minus D, means directly proportional to R here. Means it is a straight line. Up to where? The D value is equals to R. And see, after that, see here what we got here, we got inversely proportional to R square, means the graph will be like this. Means it will never be 0, means it will be goes on, maybe at infinity it becomes 0. Means here the value of 0, see here, okay, when is this one? Means that if the R value is greater than the radius of the earth. Okay, see, radius of the, more than radius of the earth, the value of G decreases. And see, less than the radius of the earth, the value of G decreases. Okay, see here the D is less than R. The radius of the earth. Okay, here the radius of the earth. Here this is equal, let's see, exactly on the surface, it is maximum. Are you following? See, at the center of the earth it is 0, and maybe at infinity it may be 0. But it will decreases. Why? Because G is inversely proportional to R square here. Here the G is directly proportional to R here. That's why it is straight line here. Are you following? See, very important graph. Let's say we got the GD value is how much here? G into 1 minus D by R. Okay, suppose you wanted to calculate the percentage change in the value of G due to depth, then how you will write here? GD minus G by G is nothing but minus D by R. Okay, are you following what I am saying? Nothing but the G minus GD by G is nothing but D by R. Okay, that you can write. Say percentage means into 100 you have to do. Percentage if you want means you have to do into 100. Okay. Okay, next see carefully here. Okay, see, have you understood this one? Okay, now see, let us look at the third case here. See, what is the third case here? The variation of G due to rotation. See how the value of G changes due to rotation here. Okay, this is another very important one. Okay, see carefully, the variation of G due to rotation. Means the rotation of the earth. Okay, see the third one here. The variation of G due to rotation. See again, see, let us observe here carefully the earth here. See, this is the earth here. Okay, so on the surface of the earth here, see, let us say, see carefully, let us take like this. See, this is the radius of the earth is R. So see, let us say at some point the mass m is there. The mass m is there. And see carefully, the earth is rotating, the mass is m here. See, it is rotating at an angular velocity omega. Means what is the omega here? Omega is nothing but the angular velocity of the earth. Okay, see the angular velocity of the earth. Okay, now see carefully here. See, this is the radius of the earth. Let us say this is the angle pi. Okay, see, that is the latitude angle. Now see, observe here carefully. Let us take it a point. See, at this point the mass is there. This radius is R here. So as the earth is rotating, see, we are on the rotating frame of reference. As we are on the rotating frame of reference, you see, with respect to this axis, here what will happen here? See, there will be a force is acting. That is, what is that force here? The centrifugal force. See, this radius is R here. It is nothing but equal to how much here? mr omega square. See carefully. See, as the earth is rotating, see, there is a pseudo force is acting. It is nothing but mr omega square. And see carefully, the mass is m here. See, the mg is acting inward here. The mg is acting inward. Okay, this is a mass m here. Now see here, see, this is pi. See, let us say this is also pi here. Now resolve into two components. Then what you get here? mr omega square cos pi. Okay, see, what is that one? mr omega square cos pi is acting outward. And the mg is acting inward. They want to tell me what the resultant force here. see that the resultant force is nothing but, see, F is equals to mg minus m smaller omega square cos pi. So what is this? The resultant force is nothing but the resultant weight which is acting here. So let us say the g due to rotation, okay, is equals to mg minus mr omega square cos pi. Let's say remove this m here. Then what is g due to rotation? It is nothing but here g minus r omega square cos pi. But it's very difficult to calculate this r value here. So you know the Kepler value, you don't know this r value. So then here what we do here, so this one is r, this one is pi. Now see here from the diagram, see what is cos pi? That is nothing but small r by Kepler. Therefore what is the small r value? R cos pi. So the small r value is nothing but r cos pi. Let us substitute that one here. Therefore g due to rotation. The g due to rotation is nothing but g minus, in the place of r, let us substitute r cos pi, omega square cos pi. Therefore g due to rotation is nothing but g minus r omega square cos square pi. This is what we want. Okay, see, are you following what I am saying here? See carefully, what is the g due to rotation here? The g due to rotation is nothing but g minus r omega square cos square pi. Now see, let us see, in this one two cases are there. See the case one. See what is the case one here? Suppose for example, so you are at equator. See, this is the equator, and say this is the pole here. Suppose you are at equator, then tell me what the pi value is 0 at equator. Okay, you are at equator then. See, when you are at equator, tell me what is the g due to rotation. It is nothing but here g minus r omega square, because see pi value is 0, cos 0 is 1. Therefore g due to rotation is nothing but how much here? G minus r omega square. Okay, see, remember this is at what? This is at equator. Okay, now see here, see the case 2. Okay, what is the case 2 here? The pi value is 90 degrees. Okay, why the 90 degrees is, suppose for example, I am here. Tell me from here, say how much angle I should rotate here? 90 degrees. Okay. Very good, Mohit. Yes, Amritvarshini, good morning, ma. Good morning. There was here, the pi value is 90 degrees. The pi value is 90 degrees here. Okay, means that you are at pole here. See, when you are at pole, now tell me what is the cos 90? Cos 90 is 0. Therefore, see what is the g at pole? It is nothing but g. Now tell me from this one what you can write here. The g at pole is greater than the g at equator. Okay, are you following what I am saying here? Are you understanding what I am saying here? Okay, see here, now I am having one question to you. See, the question is that suppose if the earth suddenly stopped. Okay, see, suppose if the earth suddenly stopped, then what is the value of g? Suppose if the earth is suddenly stopped, then what is the value of g? Come, by the time I will rub here, please tell me your answer. Okay, see, this one you understood, I think. Okay, please tell me. Suppose if the earth suddenly stopped here, then tell me what is the value of g? Yes, how much? Come on, everyone. See, suppose earth suddenly stopped. Okay, see, this is another important case. See the case 3. Okay, see the earth stopped here. The earth is stopped. Okay, so if the earth is stopped here, Mohit 0. No. It's not 0. Remains same. Very good, Sai Pradip. That's a very good answer. See carefully, if the earth stopped here, means what here? The omega value is 0. Okay, see carefully, the omega value is 0. The omega value is 0, but see here, the g is there. Then we see what is the g due to rotation? It's nothing but g. See, remember the value of g remains. See, the value of g basically depends upon what? The mass of the earth, the density of the earth, the radius of the earth. But it does not depend upon omega. See, due to omega, the change is there. Okay, are you following what I am saying here? Okay, means here, see, today what I explained here, see, I explained about what is that is called, see, the Newton's universal law of gravitation. Okay, the Newton's universal law of gravitation. Okay, good, go ahead. And then see here I explained about the acceleration due to gravity and how the acceleration due to gravity changes due to depth, due to height and due to rotation. And also see here how the value of G at the equator and pole and when it stopped. So there are cases I explained. And see, remember, see, based on this one, see, I gave you one worksheet also. Okay, around 15 problems are there. Please solve them. Okay, and please remember, see, tomorrow onwards. Yes, good morning, sir. Rajastro, sir. Okay, see carefully, see here. See, tomorrow onwards, see. Okay, it's not a live one. It's not a live one. See, I'm going to provide one video every day. Okay, having at least 10 different formulae on one concept. Within 3 minutes, I am going to give you that. Means it's like a snippets or like a very, very small tablets like that. So that you will be learning the concept. And also in the description box, I'll be giving you that concept also. Okay, just observe the 3-minute video. It's a very, very small video. So in a less time, you'll be learning a lot. So like that videos I wanted to make because I wanted to cover the syllabus as many points as possible before the mains and NEET exam. Okay, that's why. Okay, anyhow, see, thank you all. Okay, based on this one, the description box, you will be getting the answer, the worksheet by evening. Okay, please kindly solve it. Okay, and in the next week, see here, I am going to discuss about the gravitational field, the gravitational potential, and the gravitational potential energy. 3 important concepts. Okay, those 3 important concepts I am going to discuss in the next class. Okay, please kindly share and like, and please subscribe to my channel. Okay, thank you all. Okay, goodbye and have a very good day. Okay, bye to all of you.